Here with our AP Calc students, going over questions 21 through 30. All right, these are the last 10 for no calculator for multiple choice. All right, here we go, number 21. All right. This question becomes super simple if you know what this is trying to ask you to do. I know it's been a long time since we did this. We did this a couple of times, and you got mad at me when I told you that this is just a very confusing way to do something that's simple. This just wants you to find a derivative. That's it.
Sorry, Dad. These are the cards for the seniors.
Okay. Now, the question is, what do we need to find the derivative of? All right? So here is our function that we're going to be looking at. Do you guys see the x plus h and then the 2x? You see that? So what do you think our function is in this problem? That's part of it. Sine of 2x. Do you know how to find the derivative of that? I think you do. What's the derivative of sine? Cosine. And then what do you have to make sure you do? Chain rule. So what's the derivative of 2x? 2, so that goes in front.
Why is it just that?
Because this right here is the fancy way of trying to find a derivative. They're basically just saying, were you paying attention when your teacher proved it? And you weren't. So if you see all that mumbo jumbo in a few weeks, you know, wait, they're just asking me to find the derivative. We just don't do that anymore because now we know all the derivative rules. So we don't use limits to find derivatives anymore. We did that for a couple of lessons, and then we had enough of that. All right, ready? 22? All right, 22. Oh my gosh. What do you see? A slope field. Guys, I hope everyone got this one right. God, what a great question. I know you guys love slope fields. You can do this with Desmos. Were you here when we did our group activity? You didn't use Desmos then, right? All right, who wants to pick a point? Did anyone who actually did it? Yes, Joel, you did it, right? No? Okay, don't worry. Yeah? Do you want to pick a point? No. Anyone want to guess a point to try to start? 1, 2. I love it. Why not? Okay, here we go. 1, 2. So at 1, 2. That looks pretty steep and positive. So I'm looking for something probably more than positive 1. All right, so let's see. What is 1 plus 2? 3. What's the absolute value of that? Could it be positive 3? It could. I can't cross out A. All right, let's do this one. What's 1 cubed? 1. That looks much steeper than 1, right? This one looks to me like a 1. So at 1, 2, that looks steeper than 1. So is it going to be B? No. So it's not going to be. I guess I'll leave it right there. It's right here. Not going to be. Okay. Let's try letter C. It says 2 cubed. What's 2 cubed? 2 cubed is 8. Could that be 8? It could. I mean, it's very steep. So maybe it's out. I can't cross that out. What about D? 2 squared. 4. Can I cross that one out? No. All right. So good. We got 1. All right. Whenever you can cross out 1, I like it. Who's got another one? Hint. Use a negative y. See how y is cubed and y is squared? It does different things to negative numbers. So you can give me an ordered pair with a negative y.
2 and negative 2.
That is exactly the one that I chose, Andrew. What up, man? Okay, ready? So here is 2, negative 2. What do you notice about that one? Positive and pretty steep, right? Okay, so here we go. What's 2 plus negative 2? 0. What's the absolute value of 0? 0. Does that look like 0? No, because 0 is a horizontal line, so it's not A. Okay, let's try C. What is negative 2 cubed? What's negative 2 cubed? Negative 8. Does that look like a negative? Does that look like a negative slope? No, negative slope would be the other direction, so it's not C, so we know it must be D, which makes sense because negative 2 squared is a positive 4. Everybody good on 22? All right, let's keep going. All right, 23. All right, so this is one where I would have used the graphing capabilities of Desmos, but I think we can sketch it. All right, do you guys remember what y equals e to the power of x looks like? Just an exponential function like that? Yeah? Okay. Why did I start here? Why did I start at that point there? Because when x is 0, what's e to the 0 power? 1. So that point is 0, 1 right there. Okay? All right. It also says we have a vertical line at x equals 1. So right here is x equals 1. All right. So hopefully you can see when I do this, right? Here's 0, here's 1. Hey, welcome, Amy. When you look at this, hopefully you see that we're going to find the volume of a solid. So the way I taught you to do this was you're going to take the integral of the area of the function, right? Because going backwards from the area gives you the volume. Does anyone know what my limits of integration are going to be? 0 to 1. Nice. We're good there. Okay. Now here's the part of the problem I think is the toughest. It says they're using cross sections and that they're using the shape is a square. So if you imagine taking this and slicing it, right? Right? It's hard because I can't do 3D drawings, right? But you're slicing a square. Do you know the formula for the area of a square? So area of a square. Actually, it's even simpler than that, right? Because the length and the width are the same. It's side squared, right? Side times side, all right? So if you look here, all right, do you see the distance for this side, right? That's the same as what? What's the same as this distance of this side? You see what I'm doing here? I'm on that point. So what's that distance there? So what am I now? No, it's not 1. It's the function, e to the power of x. Right? See how I'm starting at the x-axis and going up to the function? So what is the length of one of my sides? Right? It's e to the power of x. And how do I find the area? I take that and do what with it? Nope, I square it. Right? E to the power of x squared. What is e to the power of x squared? No. It's e to the 2x power, right? Do you remember from your days in algebra? When you do a power to a power, what do? You multiply them together. And x times 2 is 2x. All right? So now, you're going to put this in. Right? This is going to replace here. So I have e to the power of 2x times dx. If I find that, that will be my volume. All right? Let's see if you can go backwards. Do you know the antiderivative of e to the 2x power? What do I always do when it's the natural exponential function? I copy it. If I were to take the derivative of this, I would copy it, but then I have to do the chain rule. What's the derivative of 2x? 2, right? Is there a 2 there? So I don't want a 2 there. I want it to be 1. So what do I have to put here? 1/2, the reciprocal. Nice. All right, so that's our antiderivative. And what are we evaluating it at? Very good. So 1 and then 0. So I'm going to do f of 1 minus f of 0. All right, so that's 1/2 times e squared minus, what's e to the 0 power? It's 1, so this is minus 1/2. And you should be able to find your answer now.
C.
No, it's B. Questions on 23. I like to think that even though maybe the being the natural exponential function makes that a little trickier. I think that's probably the simplest way they could ask you a question like this on the AP exam, because they're using the cross sections are squares. And everyone, at least I hope everyone knows the area for a square, right? So you have to know the area formula. The ones that are tricky is when they use, like trapezoids. Do you remember the area for a trapezoid? 24. Okay, they give us the graph of f of x, and they're telling us what is the value of this integral right here, right? Do you guys remember when you see an integral of a derivative, what is the antiderivative of the derivative? The original function. So what's the original function for f prime of x? Don't think so hard. It's just f of x, right? If I go backwards from the derivative of f of x, I'm just at the original function, right? If you back up a step. So now, if this is my antiderivative, right? That's my antiderivative. All right, how am I going to evaluate this? We need our limits of integration. What are the limits of integration? Let's start with the largest one first. 12 and 0, right? So I'm going to plug in f of 12 minus f of 0. And where am I going to find those numbers? In the graph, right? That's the whole point of giving the graph. So I go to 12. What is our function value? -4 minus, here's 0. +4, what's -4 minus 4? Sad.
That was easy.
You would have gotten it wrong. You said 0. Right? It's one of those things where, after I explain it, I hope you think it's easy, right? The question is, can it be easy before I explain it? Bless you. All right? That's the real question. If it's easy before I help you, you're going to crush it. Oh, man. Everyone should be able to get this one right. We literally just did this. Do you want me to give you some time to do it? So you can feel that moment of I got this one right? And he says, no, I don't need it. No? Anybody want that moment of I can do this myself?
I like that moment when we do it as a group. I say that was easy.
Okay. Anyway, it's saying...
We don't get this.
Are we? We're almost done. Here are 4 differential equations. Why are they called differential equations?
Because they got derivatives.
Very good. They have derivatives in it. All right. And so this, one of them out there, right, of these 4, this one's going to be a particular solution. Do you remember how to do this? Natalie's saying yes. Natalie, can you tell us? I definitely have to do the first derivative, right? Because this one has it and that one does. But if those don't work, then what am I going to have to do? Take the second. So let's start, right? On the AP exam, you don't want to do more work than you have to. Okay, any exam, right? So you're going to just do the first derivative and cross your fingers that it's which one? That it's the first one. Let's hope so. Let's hope they were nice. Oops, sorry. What's the derivative of this? I copy it down. The chain rule, what's the derivative of 6x? 6, but there was already 2 there, right? There was already 2. So 6 times 2 is 12. Nice. There's no derivative for the constant. So let's see if this works. Please let it work. So this is answer choice A. All right, so we have 12e to the 6x minus 6 times 2e to the 6x minus 5 minus 30. And please let that be 0. Oh, man. This is so live.
We got it.
It's 0. Gosh, thank you, AP exam.
I got that right.
Well done. Now, I want to make sure you guys understand, because you may not get this lucky in a few weeks. Right? So if it's not this, what am I doing? Plugging into the second one. If it's not that one, then I've got to pause for a moment to find the second derivative, because these differential equations have the second derivative. So make sure you're doing both of those. Okay. 26. Okay, this is asking for which value of x is a minimum value of this function. Now, what a lot of you guys would do if you had technology is you would type this in and just look where's the lowest value between 0 and 1, right? Sadly, we can't do that. We're going to use some calculus. So the way to do this is something I taught you called critical points. Okay, here's how you find critical points. Critical points occur, right, whenever your derivative is equal to 0. So we're going to find the derivative, set it equal to 0, and find that x value. That could be our minimum value. Okay? So let's find the derivative. Pretty tricky here. All right, I see 3x to the 4/3 power. All right, so what am I doing there? What am I doing with that 4/3? To the front, it multiplies by 3. What's 4/3 times 3? It's 4. Nice. Right, 4/3 times 3. The 3's crossed out. All right, now you remember this part? How do I get my new power? Take away 1. What's 4/3 minus 1? A third, right? 3/3 is 1, so 1/3. Okay, and what's the derivative of negative 2x? Negative 2. All right, and I want to solve this by setting it equal to 0. All right, so we can do that. Move the 2 over. Divide both sides by 4. How's everybody doing? Everybody okay? I know I go quick on the algebra. Now, let's see if you can do this without changing it to a radical. All right, do you know how to get rid of that 1/3 power? Close, not cube it, right? Because essentially, this is the same as what? The cube root. All right, so if you want to get rid of the cube root, you have to cube it. So I'm going to cube both sides. All right, so do you know how to cube 1/2? Andrew, gosh, so good, man. 1/8 is right. 1/2 times 1/2 times 1/2 is 1/8. Okay, now hold on. Hold on. I didn't say this was the answer. I said this could be the answer. Okay, you could have a critical value like a maximum or a minimum at this value. But because we're focused on this interval, you need to plug in 0, 1/8, and 1 into your function, right? Into your function, and see which one has the lowest value. Why did I say lowest value? Because we're looking for the minimum. So looking for the lowest y value. All right, so let's plug in. This is me plugging in 0. So I have y equals 3 times 0 to the 4/3 power. That's 2 times 0. Okay, I think we all kind of know what the 0 raised to any power is going to be. Right, it's going to be 0. 0 times 3. 0 minus 0. So this ordered pair is, I get 0, 0. Yes, everybody good? Okay, now I'm going to plug in 1/8. So y equals 3 times 1/8 plus u. All right, this is pretty tricky here. Okay? The way that you can rewrite this if you want, right, as a radical, all right? Do you remember what to do with these parts of the fraction? What's that called? It's on the hook. Index, right? And so I put 1/8 here, and then I raise it to the 4th power. So I think we can do this because we just went backwards from this. What's the cube root of 1/8? What's the cube root of 1/2? Nice, it's 1/2. All right, and then I want to raise it to the 4th power. So it's 1/2 times 1/2 times 1/2 times 1/2. What up, Joel? It's 1/16. So this is going to be 3 times 1/16 minus 1/4. So that's 3/16 minus 1/4. How can I rewrite 1/4? No. I'm going to write it as 4/16. So 3/16 minus 4/16 equals negative 1/16. So here's my ordered pair here. All right, not done yet. We still need to plug in the other endpoint, 1. So if we plug in 1, we're close. Okay, 1 to any power is going to be 1. What's 1 times 3? 3. And then 2 times 1 is 2. So 3 minus 2 is 1. So this is 1, 1. Okay, so analyze your y values. I'll highlight them for you. Look at your y values. We're looking for the minimum. So which one has the lowest number? 1/8. So 1/8 is right. But was it right because I just found it? No, I need to plug it. Because what if this problem said, which one has the maximum value? Which one is the maximum? Which one has the x value where the maximum is? Which was the highest number? Which was the highest number? 1. So the answer would be 1 if this had said the maximum value. Are we okay? That one was challenging. But the key takeaway is when you want to find critical points, how do you find critical points? Find the derivative and do what with it? Make it equal to 0. There's the critical points. Okay? Gosh, man. So good. All right, 27. I think we can do this one without any math. Just reading. So I'm going to give you 30 seconds to read everything. I'm going to give you more time. I'm going to pause it. All right, so when I read this one, the first thing that I focused on was, what does W of t mean? It tells you the rate of the depth of the water, right? The rate of the depth of the water. So when you take the derivative, do you know what a derivative means? A derivative is just a fancy term that we've used in calculus to mean a rate of change. Okay? So whenever you see a derivative, that's just a fancy way of saying rate of change. So we're talking about the depth of the water, right, is increasing at a rate that we call WT feet per hour. So we're talking about the rate of change of this is going to be greater than 3 at time 2. So when you read your answer choices, I like these two, like picking between, because they're saying at time t, right, 2 hours after, right? So at time t, not over the 2 hours, because we're saying literally at this moment in time, 2 hours later, not over 2 hours, okay? I think this is saying W of t, but this one, because it's saying the rate at which the depth of the water is rising, right? So that's a rate of change, so that's why it's C. All right, so really this is a question of, do you know what the basic idea of a derivative is? Okay. 28. Oh my gosh, love this problem. So good. You've got trig rolled up in calculus. I mean, what is better than that? Nothing. All right, you ready? All right. And they even give you a drawing. This looks just like the drawings I do. All right, where it's a stick figure and a little balloon. I literally just did this drawing yesterday with my juniors in pre-cal. I should show this one and you should feel like, hey, I can draw just as well. Okay. We have a person. There's our person standing 30 feet from point P. Gives you that on the sketch. They're watching a balloon go up in the air. All right, so the next time you watch a balloon, what are you thinking? You're thinking calculus, right? Okay. We want to know if the balloon is rising at a constant rate of 2 feet per second. So telling us the balloon is going up. Oh, yeah, 2 feet per second. Makes sense. What's the rate of change of the angle at the moment it's 40 feet above point P? Okay? The moment it is. So here's what I do first. The first thing I have to do is I need to write down some equation that's going to add all this together. Okay? So what I notice is they're talking about this side, right? Talking about this side in terms of the balloon going up, right? Here's our angle theta, right? You got to go all the way back to your days in geometry. How would you describe this side from this perspective of this angle? It's the opposite side. Not a great start, okay? How would you describe this one? Adjacent. Do you remember what trig ratio we use for opposite and adjacent? Tangent. The height of balloon over 30. How's everybody doing? That's the geometry part. Here's the calculus part. Now we're going to take the derivative. Okay? So when I take the derivative of tangent, do you remember the derivative of tangent? It's okay if you don't, right? Didn't make you memorize it. It's secant squared. Nice. All right, now here's the tricky part. You write secant squared theta, all right? But here's what students forget. And when we did this in, I think, unit 5 or 6, make sure you also put, right, the differentiation after. So you're going to write times d theta over dt. That's that rate of change that the angle is changing, right? Because what's happening to the balloon? It's going up. So as I'm looking up, what's happening to that angle of elevation? It's getting higher. It's increasing. So this right here models that. That's that change in that angle. It's going up. Okay? All right, equals. Let's do the other side. Okay? The 30 is a constant. So what I do is I just write 1/30th here. All right? Because what's the derivative of h? What's the derivative of any variable?
1.
Just 1. But be careful. Right? It's not just 1. It's 1 then times dh over dt, right? It's always with respect to time, right? Because it's changing over time. Okay, now we know some of this stuff. Okay? Let's see. What do we know? Excuse me. We know the balloon is rising at a constant rate of 2 feet per second. So that is dh over dt. So I'm going to write dh over dt is 2. All right, so I'll be able to plug in 2 here. Okay, what am I solving for? What am I solving for? It says, what is the rate of change in radians per second of angle theta? So what am I solving for? D theta over dt. This is what I'm solving for. So I'm solving for this. So that's the only thing I can't know, right? Because I need to solve for that. So the question is, can we find the secant squared of theta? And the answer is yes. Okay? So let's see what you remember about secant. Do you remember anything about secant of theta? Really? It's the reciprocal of which trig function?
Cosine.
It is cosine. So it's 1 over cosine. All right? Now, do you see what kind of triangle we have? A right triangle. At what moment are we trying to calculate this? The moment the balloon is how high up? 40. So if I make h, right? If I make h 40, this is 30. This is 40. Can I find this side length?
Oh, yeah.
Yes. With Pythagorean theorem. All right. Now this one is, they're trying to give you like a softball here. You may not recognize it, but if this is 30 and this is 40, do you know what the hypotenuse is?
20.
Has to be bigger, right? How about it's always the biggest one?
Oh, that'd be 180, right?
Right? Because I remember Mrs. Foltz, back when I was 14, she taught us special right triangles, 3, 4, 5. So if it says 30, then 40, so it's 30, then 40. The hypotenuse is 50. Do you need me to prove that? I can prove it. Ready? So we have 30 squared plus 40 squared equals the hypotenuse squared. All right? Gosh, I don't think I know. I think I can do this. 40 squared, 1600. Oh, yes, my SAT score. No, just joking. Clearly did not get that. Okay, so how do we get the hypotenuse? Take the square root. What's the square root of 2500? It's 50. All right? Anyway, that's it. Supposed to be a gift for you. All right, so now, if you're telling me that secant is 1 over cosine, can you tell me what cosine is? All right, do you remember what cosine is from SOHCAHTOA? Close, that's sine. Adjacent, right? So ka-toa, right? So we have cosine is going to be adjacent, right? Adjacent over the hypotenuse. So 30 over 50. But do I want cosine? What do I want? Secant. So what do I have to do to get secant? Reciprocal. And then do I want secant in my formula? I want secant squared. Be nice to yourself, guys. How can you reduce 50 over 30? 5 over 3, right?
Oh, yeah.
Yes, I flipped it. So I'm going to write this down. I'm ready to plug in. Here we go. 5/3 squared times, I'm solving for this, 130. And what did I say is my rate at which the balloon is going up? 2. Nice. And now it's algebra, right? It's complicated algebra, but it's still algebra. All right. So this is 25/9 times d theta over dt equals 2/3. How do I get that d theta dt by itself? You bring it over. How would I bring that over? I really just want to say when it's a fraction, I'm not going to divide. I'm going to multiply by the reciprocal. So I'm going to write 2/3 times 25. No, flip it, 9/25. Okay, so I can reduce the 9 over 3. That's 3, and that's 1. All right, so I get 3. Oh, I did something wrong, Dennis. What did I do? Somebody's going to tell me what I did wrong. Oh, for Cal, you're supposed to tell me. Why did I write 1/3? Sorry, guys. That's on me. People watching at home, I'm not perfect either, clearly. So I can reduce 9/30. That's on me, my bad. That's going to be 3/10. All right, divide both by 3. Sorry about this. So you have 6 over, I can do more reducing. What did I do wrong? I did something else wrong. What did I, somebody found it. Somebody found it? No. Because that reduces to this. Can you not reduce until the end? I guess you can. Okay. Okay. I didn't do anything wrong. It's 3 over 125. Man, I was going so well on that too. Sad. All right. My bad.
It's all good.
It's not all good. I want to do it right the first time.
You did.
It's okay. I just forgot the 0. Now, can we review that real quick? Because that was a lot. So the first step when you get this is called a related rates problem. We have done this. I know you're thinking, man, we did this, okay? Related rate problems, first thing you have to do is find an equation that relates your values. All right, so what I'm saying here is we found an equation that related our theta, right, our angle, as well as our height of the balloon. So we wrote that, and that happened to be a trig equation, okay? Once you do that, you take the derivative. When you take the derivative, don't forget all of your rates. Right? Don't forget those rates based on your variables. All right? And then once you do that, hopefully you've got everything you need. If you don't, like in this case, we had to do a little bit of a Pythagorean theorem moment to find everything we needed. All right? But that's kind of the process for doing this. Let's go to 29. We're almost done, guys. 2 more. You're doing awesome. All right, 29. I really don't think this is a calculus question. I really think this is an algebra question. Do you remember how to find vertical asymptotes when you're given a rational function? It's whatever makes where the what? The bottom 0. Whatever makes the denominator 0 will give you a vertical asymptote. But be careful here, because when I look at this, I should be thinking, what can I do first? You can do dots. What up, Matthew? Oh, so good, man. All right, ready? Let's do dots. Matthew, since you said it, all right? Joel will tell you that's your first mistake. How would I do dots for x to the 4th power minus 16? Do you know the square root of x to the 4th power? You're good. My question was, what's the square root of this? Nice. Okay. And then I think you know the square root of 16. What she said? Did I? I was just looking away. I didn't want to make you feel nervous. Okay. Everybody okay? Oh my gosh, Matthew. What just happened? You guys have seen the movie Inception, right? Yeah? Where it's like dreams within dreams within dreams. Dots within dots. I mean, gosh, what a day. What a day. All right, so this one's going to be x minus 2, x plus 2. Oh, that's plus 4. Okay. Now we're ready to talk about it. All right, as bless you, my daughter would say at the end of bedtime, I want to talk about stuff. Okay. She wants to like go through her day. So I always ask her, what was your, the part of the day you felt happiest, and then the part of the day that you felt was a challenge. And most of the time she says her challenge was dealing with her brothers. So, at least there's that. Consistency. What do you notice about the numerator and the denominator? You got one crosses out. Do you remember what that creates? Right? Think of your favorite, what's that book? Or what's that movie based on a book? Your favorite, what's that guy's name? Oh my gosh, the actor. What is his name? What is his name? It's a movie based on a book. He was a kid, now he's older. What is his name? Gosh, he's in that weird movie called Honey Boy. What is his name? God, he was in Eagle Eye. Oh gosh, I can't think of his name. No, it's gonna hit me. I can see his face. Oh my gosh. Anyway, it creates what?
It starts with an H. A hole.
A hole. It does start with an H. A hole. What is that guy in Holes? The movie holes? Thank you. Gosh, Andrew, this is why you're here, man. I couldn't think of his name. I see his face. Couldn't think of his name. Gosh, good thing you're here. Man, Shia LaBeouf. Holes, right? Creates a hole. Now we're in calculus. That was so yeah, very busy, right? Teaching. That was so a algebra concept. Now in calculus, what do we describe that when you have a hole? What's the name we use for a hole in calculus? A discontinuity. What type when it's a hole? What up, Annie? Removable discontinuity. God, who needs Michael? Well done. All right, so this is gone. That's gone. Right? So I'm only focused on these two. Can I make them both 0? I can make that one 0. What makes that 0? -2. What about this one, though? Focus on that one. Can I make x squared plus 4 0? No, because whenever I square something, what does it become? Positive. Adding 4. Not going to make that negative. So how many vertical asymptotes do we actually have? 1. Should I do it again? We'll do it again. Right? Remember, this is gone. It's not in the running anymore. Right? That's a hole at x equals 2. So it's really down between these two. And we just said we couldn't make that one 0. So the only one that we can make 0 is that one. So that means we only have one vertical asymptote. All right, let's keep going. Last question, guys, for today, and then we're done. All right, so Amy, if there's time, I can write you past Mr. Hernandez. All right. Now this one, gosh, it's so tricky. And it's a long time ago that I taught you guys this, or we even looked at it, but this is called a Riemann sum. Gosh, it's been a while. And I taught you guys that to find the change in x, so the delta x that we use for like our width of each, remember each of the bars that we use, right, is to do the difference of your limits of integration over how many intervals you want. Okay? All right. And for a Riemann sum, and I didn't focus on this, so this is on me. I need to do this next year a better job. Do you see this part here on this summation? You see that last part, 2 over n? Sorry, I don't want to get that squared in there. Do you see just the 2 over n? Right? That 2 over n, if you get this problem on the AP exam, is your delta x. That's your change in your x. All right? So if you get this, and they give you a Riemann sum with the limit of your summation symbol, then you need to look at the very end of it. That is your delta x. So, all right, if this is going to be true, then the difference in our limits of integration, all right, has to be equal when I set this up. So here's how I set it up. We know one of the limits of integration is 1. We're trying to figure out what this one is. So let's imagine it's 2, right? The answers are there. Let's try 2. So the first one is 2 minus 1 over n. It has to equal what? What is my delta x? I highlighted in blue. 2 over n, right? Okay, so let's see if this is true. So focus on this proportion. What's 2 minus 1? 1. Right? Is this a true statement? No, it's not. Right? So it's not A. Let's try letter B. Okay, so I'm doing 3 minus 1 over n equals 2 over n. Does this end up being true? Yes, it makes 2 over n equals 2 over n. So for number 30, it has to be B for this to be true. Because I did the next number, if I did 4, right, it would not be true. 5, any number after that, it won't be true. All right, so if you get this question or this type of question, make sure you're focused on, okay, look at the very end. That's your delta x, and try to use what we focused on, this right here, to find that change in x. All right, guys, that is it for today.